Imagine driving a sleek electric vehicle down a quiet road, feeling the satisfaction of zero emissions and the belief that you're contributing to a cleaner, greener planet. It's the promise of a sustainable future that EV advocates have championed. But what if that electric car isn't as environmentally friendly as it seems? Beneath the surface lies a hidden story of significant environmental costs tied to the production of EV batteries, costs that are often overlooked in the rush to embrace green technology. Let's take a closer look at the unseen side of electric vehicles and the challenges that come with the batteries that power them. Electric vehicles run on lithium-ion batteries, an impressive technology that powers everything from Teslas to smartphones. However, the materials needed for these batteries, lithium, cobalt, and nickel, are extracted through environmentally destructive mining practices. Lithium, for instance, is primarily sourced from salt flats in regions like Chile, Argentina, and Australia. The extraction process involves pumping massive amounts of water into the ground to create a brine that contains lithium. This practice often drains local water sources, threatening ecosystems and the livelihoods of farmers who depend on them. In some areas, lithium mining has resulted in severe water shortages and left behind barren, dried-up landscapes. Cobalt, another critical material for EV batteries, is mostly mined in the Democratic Republic of Congo under troubling conditions. Beyond environmental degradation, cobalt mining is linked to human rights abuses, including child labor. Toxic waste from mining further contaminates the soil and water, leaving long-term damage. These social and environmental costs often go unnoticed in the push to promote EVs as a clean alternative to traditional vehicles. While EVs are celebrated for their zero tailpipe emissions, the process of making their batteries leaves a large carbon footprint. Battery production is energy-intensive, requiring vast amounts of power for mining, refining, and assembly. Much of this energy is still derived from fossil fuels, meaning that the production of a single EV battery can generate as much carbon dioxide as driving a gasoline-powered car for several years. Additionally, the global supply chain for battery materials adds to the problem. Lithium mined in South America may be refined in China and then assembled into batteries in Europe, requiring transportation across thousands of miles. Each step adds to the carbon emissions associated with EV battery production, complicating the narrative of these vehicles as inherently eco-friendly. The environmental challenges don't end once a battery is installed in a vehicle. When an EV battery reaches the end of its life, disposal becomes a significant issue. Recycling lithium-ion batteries is a complex and expensive process that requires specialized facilities. Currently, the infrastructure to recycle these batteries is limited, meaning many end up in landfills where they can leak toxic chemicals into the soil and water. As the number of EVs grows, so does the potential for a massive buildup of battery waste, creating a new environmental hazard. Additionally, EV batteries have a limited lifespan, typically lasting 8 to 15 years before they degrade and need replacement. This cycle of frequent manufacturing and disposal only amplifies the environmental impact. Despite these challenges, EV advocates often focus on the benefits of zero emissions, while ignoring the broader environmental costs. The allure of clean technology and the promise of reducing air pollution dominate the conversation, creating a simplified narrative that overlooks the full life cycle of an EV. While the goal of reducing emissions is commendable, this tunnel vision obscures the complexities of battery production, transportation, and disposal. To make EVs a truly sustainable solution, several critical steps need to be taken. First, investing in battery recycling technology is essential. Developing efficient recycling processes can repurpose old batteries, reduce the need for new mining, and lower the overall environmental footprint of EVs. Governments and companies must prioritize building recycling infrastructure to address this growing challenge. Second, exploring alternative battery technologies could provide a path forward. Solid-state batteries, for example, offer the potential for more efficient and longer-lasting energy storage with fewer harmful materials. Continued innovation in this space could significantly reduce the environmental costs of producing EVs. Third, sustainable mining practices must be implemented to minimize the ecological and social impact of extracting battery materials. This includes stricter regulations, better oversight, and investing in technologies that reduce the harm caused by mining operations. Protecting the rights of workers and ensuring the fair treatment of communities near mining sites are equally crucial. While electric vehicles hold promise as a cleaner transportation option, they are not a perfect solution. The environmental costs associated with their batteries, ranging from destructive mining practices to high carbon emissions and toxic waste, must be addressed. Embracing EVs as part of the green revolution requires confronting these challenges and investing in sustainable practices that consider the full life cycle of battery production. It's time for EV advocates to look beyond the tailpipe and consider the bigger picture. Real environmental progress demands more than just cleaner driving. It requires a holistic approach that addresses every step of the process, from mining to manufacturing to disposal. Only by tackling these hidden costs can electric vehicles truly live up to their potential as a sustainable alternative. Let's move towards solutions that balance innovation with responsibility, ensuring a future that benefits both people and the planet.